Good morning, Mom. For our Chapter 10, we have the nature of codes and cryptography. In this era of technology and advanced communications, enormous information or data, it can be text, numbers, images, and graphics, are sent from one point to another point through different media. It is very important that these data are conveyed in their original form and are not corrupted during transmission. Coding theory and cryptography play a particularly significant role in data transmission. What is the difference between coding theory and cryptography? When we say coding theory, it is associated with error-correcting codes. Coding. So what really is coding? It's kind of telling a computer what to do with specific instructions made just by you. For example, have you ever wondered how computers do the things they do, like play movies or show pictures or make music? How does it know what to do? Computers know what to do because of the word coding. Think of it like a recipe book when you want to make your favorite food. When the computer is turned on, it needs instructions. And when you ask it to do something like use Netflix or YouTube or anything, it's like giving a recipe how to do it. But instead of ingredients, it uses called programming. They have language like Java or Python. You can do whatever you want with coding. That's how they make video games, how they make websites. When we say cryptography, it is concerned with the security, privacy, and confidentiality of information transmitted over a secure channel. In cryptography, let's imagine two people who share an important secret that needs to be told. It requires communicating private information for a distance. Since it's private, they need to use letters and some kind of secret code for them to be able to i-secret yung message na yun. Kasi baka malaman ng iba. Dapat sila yung nakakaalam. Para yung cryptography. Nag-send sila ng cryptic message na nagiging alien yung words sa ibang tao kapag nabasa nila yun. So cryptography begins when we abandon physical locks and we use ciphers instead. The most famous cipher is Caesar cipher. The term coding is basically associated with three areas. These are data compression, is concerned with the efficient encoding of source information so that it takes a little space as possible. It reduces the amount of space needed to store files. So dito from the word itself, data compression. So kinocompress yung data, ibig sabihin, imbis na maraming words yung ito-type or naka-paragraph pa yung information, pinapaikli na siya para mas madami pang available spaces dun sa pag-encode. So naging efficient siya. Next is error-correcting codes. These are concerned with the authenticity, safety, correctness, integrity, and reliability of communication every noisy channels. And these are numbers appear on computer screen to show that you made a wrong in program. So dito, make sure na accurate yung mga codes and safe yun. Cryptography. Sinasabi ko na yung sa cryptography. It is concerned with the security, privacy, or confidentiality of communication over an insecure channel. So, mas discuss siya sa mga susunod na slides. Now, we have efficient communications. All forms of life communicate. People communicate with each other, verbally and non-verbally. Animals like cats communicate with each other with their meows and body language. peacocks can fan their feathers in an impressive visual display intended to communicate a territorial warning. Yung dolphin naman, may slap its tail on the water to get the attention of others in the area. We have bees also. They tell other bees when they have found nectar by dancing when they return to the hive. And umikot yung mga nila. Nagdadance sila. Lastly, deer flick their tails to warn other deer following them of possible dangers ahead. Communication is all around us. It is imperative that the desired message is sent and received. Efficient communication is the best, or the ability to deliver a clear message in the shortest amount of time. Yun nga, efficient. So, kailangan kapag nag-communicate tayo, masasend natin yung message and ma-receive din kung ano yung gusto natin iparating. So, naging efficient siya kapag na-receive tapos na-send mo. Tapos, napadala mo siya in the shortest amount of time. So, walang barriers, wala masyadong noises kasi napadala mo siya kaagad. So, efficient communication yun. So, napakahalaga nun para sa atin ngayon. With this form of communication, the message may or may not be received in the manner intended. The receiver may feel the brevity is insufficient and may need more clarity in order for the message to be delivered effectively. Being able to master efficient communication in business, in classrooms, in the confines of our homes, and anywhere else exerts a vital and positive impact on the professional and personal relationships of everyone involved in the communication. So we have the diagram that shows how the communication process operates. Siyempre, meron tayong source kung saan nanggagaling yung message. Source coder, channel coder, kung anong gamit yung pinatransmit niya ng code. Tapos yung decoder, kung paano din na-receive. So, in between yan, merong noise. Ito yung mga barriers nga. Like in electronics. When we say noise, it is an unwanted disturbance in an electrical signal. It is generated by electronic devices. It varies greatly as it is produced by several different effects. In communication systems, noise is an error or an undesired random disturbance to a useful information signal. The noise is a summation of unwanted or disturbing energy from natural and sometimes man-made sources. Ayan, meron tayong channel decoder, kung paano na-receive yung code. Tapos yun, source decoder, yung receiver. That's it in the communication process.
Good day po, Ma'am Agli. Now, I'm Patrick Miguel Carlos po. So, sa part ko po, I'll be discussing cryptography and substitution cryptography, cipher. So, cryptography. Sending information all over the internet is equivalent to writing a message on a postcard. When a postcard is sent through the mail, anyone who has access to the snail mail can read the message to the recipient of the postcard. So, when people send information over the internet, they want that their information to be unreadable or undecipherable, nor understood by people who are not the intended recipients of these messages. Also, the pieces of information are supposed to be safe, not stolen nor altered during transmission. This is where cryptography comes in. Cryptography can be used to authenticate users of information and computer systems. It is an indispensable tool used to protect information in computing systems. It is used everywhere by billions of people worldwide on a daily basis. So, yung cryptography, ginagamit na siya noon pa man. So, hanggang ngayon, patuloy pa rin siyang ginagamit. Ginagamit yung cryptography so that yung target mo or yung pagbibigyan mo ng message, siya lang yung makakaintindi ng message na ibibigay mo or ipapadala mo. So, yung cryptography, ginagamit pa rin siya sa paggawa ng passwords, pati na sa mga bank cards. So yung cryptography, meron siyang tatlong areas. Ito yung symmetric key cryptography, hash functions, and public key cryptography. So symmetric key cryptography. So symmetric key cryptography is a single key shared by both sender and receiver. This single key is used by the sender to encrypt his or her message called plain text and sends the cipher text to the receiver. This single key is the same key that the receiver used to decrypt the ciphertext to recover the plain text. So yung symmetric key cryptography, para ma-decode mo or ma-decrypt mo yung isang message, kailangan yung pagbibigyan mo ng message is merong same na key para makita niya yung plain text doon sa mismong context na binigay mo or doon sa mismong message na pinadala mo sa kanya. So next one is the public key cryptography. So public key cryptography, there are two related keys, public and private keys. The public key may be freely distributed. The private key must not be divulged and must remain a secret. The public key is used for encryption and the private key is one used for decryption. So yung based dito sa description, yung public key used for encryption lang siya. So it is okay to distribute it freely sa public since it is a public key. Pero yung private, dapat secret lang siya. Doon lang siya sa pagbibigyan mo ng message or doon lang to pagitan sa sender and the receiver. So yung plain message or yung plain text message, yung receiver lang magkakaroon ng access doon sa message na yun. So the last one is hash function. Ito, hash function. Yung hash function, there is no key being used. The hash value is computed as per the plain text that makes it impossible for the context of the plain text to be recovered. Hash functions are also used by many operating systems to encrypt passwords. So, yung hash function, it is a function or programs that use a mathematical function like an algorithm to convert information to hexadecimal form. So, etong function din na to is ginagamit sa cryptocurrency to secure blockchain information doon sa loob ng system ng cryptocurrency. Kasi sa cryptocurrency, isang mali mo lang, pwede ka talagang ma-hack, then lahat ng ipon mo doon sa cryptocurrency is mawawala. So next naman is ito pa pala, there are two steps involved in cryptography, which is decryption and encryption. So encryption is the process of encoding a message or information in such a way that only authorized recipients can access and those who are not authorized cannot. So ayan, dun naman sa decryption, yung decryption naman, since yung encryption is process of encoding, decryption naman is decoding. So dito, pag na-decode na yung message or information, dun na maintindihan ng recipient yung message na tanging sa kanya lamang sinend, kasi siya lang yung authorized recipient na maka-access doon sa message na pinadala sa kanya. So next one naman is the substitution ciphers. So substitution ciphers. So, substitution cipher. This a simple method. In this method, each letter in the message is replaced by another letter following some established mapping. An example of substitution cipher is called the Caesar or shift cipher. This is considered the earliest known use of cryptology developed by Julius Caesar. According to literature, he made secret messages by shifting each letter 3 letters forward in the alphabet. To express the Caesar's encryption, mathematically first replace each letter by an integer from 0 to 25, corresponding to the letters of the English alphabet, where A is equal to 0 and Z is equal to 25. The Caesar's encryption can be represented by a function f that assigns to the non-negative integer p, and p is less than or equal to 25. The integer f of p is a set of 0, 1, 2, up to 25 with. So, ito yung kanyang formula. Diyan. So, the encrypted letter represented by M is replaced with the letter represented by M plus 3, mod 26. So, yung M, ito yung encrypted letter. So, dahil nga dito kay Julius Caesar, yung secrets, yung ginawa niyang secret messages, sinishift niya yung each letter by 3 letters forward. Ito, 3 letters forward. Kaya, plus 3 dito. So, M plus 3 kung ano yung next niyang letter. I mean, next 3 letters. Kunwari, M. Kunwari, yung, for example, yung value ng M is natin A. So, plus 3 magiging ano yan? A, E, C, D. So, dito magsisimula, di ba? A na siya. So, plus 3 pa. 1, 2, 3. So, yung equivalent ng letter A is B. Ganun siya nag-work. So, Caesar encrypted letter represented by M is replaced with the letter represented by M plus 3 mod 26. The Caesar's encryption use modular arithmetic. Modular arithmetic states that if A and B are the integers and N is a positive integer there, then A is a congruent to B modulo N if N divides A minus B. The notation for congruence modulo is A is equal to B to indicate that A is congruent to B modulo N. Two numbers are congruent mod 26 if they leave the same remainder when divided to 26. So, eto. May isa pang example. So, sa example number 1 naman, say that the original message is God bless you. So, if a shift of 5 letters is used, then the encrypted form of this message will be LTIGQJXXDTZ. That is a shift of 5 letters means A will be replaced by F, B will be replaced by G, C will be replaced by H, and so on. So, ganito siya. So, paano nakuha yun? Yung sa God bless you. So, G plus ilan yung shift ng letters na sinabi dito? 5 daw. So, 5 letters forward. So, we receive G, H, I, J, K, L. So, L yung katumbas ng G dun sa Caesar cipher is L. So, ayan, L. So, next naman is yung sa O. Yung sa O naman, so O plus 5. So, O, P, Q, R, S, T, T. So, T yung kanyang kasunod. Ganyan yung ginagawang decoding dito sa Caesar or shift cipher. So, meron pang ibang example sa ito. Kita natin. Ito. Delete lang. Yan. So, dito sa example number 2, use the Caesar cipher with shift of 10, then keep the message, I will love you forever. So, use the specified mapping use SG, SVV, VYFO, IYE, PYBOFOB. So, ayan yung na-decode na cipher, Caesar cipher or shift cipher. So, paano natin malalaman kung tama ba yan? So, ganito. I plus ilang shift yung ginawa natin dito. Nakalagay dito is 10. So, 10 plus 10. So, magbibilang lang tayo. HIJKLMNOPQRS. So, S. Yung S with this shift of 10, yung I magiging S. So, tama tong una. So, sunod naman W. So, W. PQRS. W. X, Y, Z. So, kapag umabot na siya sa Z, ulit lang, babalik lang siya doon sa letter A. So, Z. A, B, C, D, E, F, G. So, tama. Yung letter W plus 10 shift forward, magiging letter G siya. So, yan, tama. Tapos, and so on and so forth. Ganun lang ginagawa dito sa Caesar cipher. So, try naman natin yung eto naman, try natin to. Example siya. So, dito, de-decode natin yung nakalagay dito. So, mali. JIACUEI na merong shift forward na 6. So, eto. So, una J. So, J plus 6. So, ano yan? J. K, L, M, N, O, P. P. So, yung unang letter natin is P. P yan. So, I, A, C. So, IAC. So, I 6 for J, K, L, M, N, O. So, O. 6. O. So, O. So, may I din dito. So, O na yan. So, A naman. A, B, C, D, E, F, G. So, G. 6 is equal to G. So, G. So, C, D, E, F, G, H, I. Ay, ito. Fourth letter natin is I. U, V, W, X, Y, Z, A. So, A. A naman dito. So, U plus 6 is equal to A na. Tapos, dito, last one, E, F, G, H, I, J, K. So, K. Ako yung tinutukoy dito. Pogi ako. So, ayan. Ganyan lang gumamit ng Caesar cipher. So madali lang siya compared sa iba sigurong cipher na mahirap i-decode. So nakadepende lang talaga to sa kung paano or kung sasabihin ba sa'yo kung ilang shift forward yung message na gagawin or ginagawa dito sa dun sa authorized na recipient ng mismong message. So yun lang po yung sa part ko. Thank you so much po sa pakikinig.
I am Polynesia Marie Aurelia, and I will be discussing transposition cipher. A transposition cipher is another encryption method in which the order of characters is changed to obscure the message. So from the term itself, transposition means nagtatransfer, transposing, nagpapalit ng posisyon. An early version of transposition cipher was a sky tale, in which paper was wrapped around the stick and the message was written. Once unwrapped, the message was unreadable until the message was wrapped around a same size stick again. So, the transposition cipher used currently is done by writing the message in rows, then forming the encrypted message from the text in the columns. And syempre, you can also create your own version of the row and column based transposition cipher. For example, the method could specify that after writing the message out in rows, you should record the third column, then the fourth, then the first, then the fifth, then the second. This adds additional complexity that will make it harder for the non-intended recipients to decipher the original message. So, ganito yan. To make the encryption key easier to remember, a word can be used. For example, if the keyword is money, it will specify that rows should have 5 characters each. So, since meron tayong 5 letters, meron tayong 5 columns. The order of the letters in the alphabet will dictate how or which order to read the columns in. So, sa money, since yung letter E, since yung letter E, ito yung money. Since yung letter E yung pinaka earliest letter in alphabet. So, instead na nasa 4th row siya, gagawin natin siyang nasa first column. Gagawin natin siyang nasa first row. Yan. So, next yung M. Imbes na nasa nasa first row, first column, andito siya sa second M. And then N, diba? Sunod MN. Tapos next yung O. And dito yung Y. So, ganyan lang po siya. Para mas maintindihan pa natin, let's watch this video. So, as you can see, yung word natin is transposition. So, as you can see, we have a keyword of 43152. Ayun yung clue and ayun yung pag-arrange ng columns natin. Imbes na yung kanina na mababasa natin yung transposition, magiging magsha-shuffle siya. So, instead na 1, 2, 3, 4, 5, magiging 4, 3, 1, 5, 2. Para mas magiging challenging kapag tinicode or pag in-encrypt. So, ganun lang siya. So, for our next topic, we will be discussing RSA public key cryptography. RSA is crypto system for public key encryption. It was introduced in 1977 by Ron Rivest, Adi Shamir, and Leonard Adleman. So, RSA, it simply stands for them. R for Rivest, S for Shamir, and A for Adleman. So, RSA is used largely to secure highly sensitive data and information, especially when this data and information are sent over networks like internet. So, public key encryption. So, RSA, public. Ibig sabihin, everyone has access on it. So, yung gumagamit siya ng RSA, public cryptography. Gumagamit ng cryptography para ma-secure yung message before mo isend yun. It also allow two communicating parties to disguise data that they send to each other. So, public key cryptography uses a pair of keys to encrypt and decrypt data to protect it against unauthorized access or use. Nagamit din to provide authenticity for internet messaging. It has application in digital signatures, secure communication protocols, like yung SSH and yung HTTPS, para malaman natin kung secured ba yung i-open mong email messages, virtual private networks, and software. So, itong RSA, it is widely used pa rin until now kasi it provides a secure method of transmitting sensitive data over the internet.
Good day everyone, my name is Darlene Joseph Malabag and I am going to discuss the congruence. Ang congruence ay madalas ginagamit sa pag-predict ng time, birthday mo, and so on. Sa pag-solve ng congruence, ang kailangan natin dito is integers. Ang mga integers katulad ng whole numbers like positive or negative. Ang mga non-integers naman is, for example, fractions, decimals. Kapag lumabas sa computation nyo ay may decimal, like 51.723, like something like that, gagawin nyo siyang whole number. Bali, magiging 51 na lang siya. Bali, tatanggalin nyo yung point something. For example, na makikita nyo sa inyong mga screens. 21 multiplied by 32, modular 30. The first thing you need to do is multiply the 21 by 32. 21 multiplied by 32 is equal to 672. And yung modulo m, which is modulo 13, ay i-divide nyo sa multiply nyo. Bali, 672 divided by 13. Use your calculators to compute. Ang sagot na lumabas sa calculator nyo is 51.692. Kaya nga nang sinabi natin kanina, pagka may decimal, tatanggalin natin yung point something niya. Magiging sagot niya is 51. Again, yung modulo 13, i-multiply natin siya sa pinag-divide natin 672 divided by 13. Bali, 51 multiplied by 13 is equal to 663. And lastly, to finalize your answer, subtract the 672 minus 663 equals 9. Therefore, the congruence is equal to 9. Try to answer this equation. Check your answers if it's correct. If you have any question and clarification with my topic, you can ask me via email, messenger, or in person. The last topic I'm going to discuss is Vigenère cipher. Vigenère cipher is a polyalphabetic substitution system created by Belz de Vigenère. It is used as a key made of letters and a table by replacing a letter by another letter, which is not always the same. This table is an example of visionary cipher. As you can see, the 26 alphabetic letters. The use of visionary cipher is for securing in the form of digital images, especially for the logos of the company, in which the cryptography, logos, or digital images that can secure during the transmission over the internet. Let's have an example. Encrypt the message "I love you" with the keyword of hug using the visionary cipher. To form the ciphertext PFUCYEVO, first, hahanapin mo yung number corresponding sa spelling ng hug, which is H is for 8, U is for 21, and G is for 7. Yung numbers na 8, 21, and 7 ay ilalagay nyo sa every letter ng I love you. And then, from that letter, for example, I is for 8. Bibilang ka ng 8 times from I, bali I, J, K, L, M, N, O, P. Sa L naman, which is 21, bibilang ka from L ng 21 times. Bali, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, A, B, C, D, E, F. And same operation lang siya sa susunod. Again, if you have any question or clarification with this topic, don't hesitate to message. And that is all my report. Thank you for listening.
Good day everyone, my name is Mmw and I will be reporting my part starting with compression and decompression. So compression, sometimes known as packing, refers to the creation of a smaller file from a bigger file. So from the word itself, compression, ito yung pagko-compress natin ng file para mas mabilis natin siyang ma-upload. So merong two types ng compression. The lossless compression, wherein walang nawawalang data kapag na-compress na yung file. While sa lossy compression, may datang nawawala kapag nag-perform ng compression. So meron tayong four formats when it comes to this. We have first the JPEG or the Joint Photographic Expert Group, which is a lossy type of compression, usually ginagamit sa pictures. Next is MPEG or the Moving Pictures Expert Group. Ginagamit naman ito usually sa mga video and audio types na file. Pang third is the zip or tar na usually nakikita natin na may zipper yung folder. Ito ay isang type ng lossless compression. Lastly, we have the hex na ginagamit sa pag-encode at pagko-compress ng files. So next, kung may compression, of course may decompression, wherein yung compressed file ay nire-restore natin to its original form. It is also called as uncompression. So next, we have the universal product codes. So, yung universal product codes, ito yung printed code na nakikita natin sa packaging ng isang product, usually tuwing nag-grocery tayo sa mga supermarkets. So, it consists of two parts, the barcode and the unique 12-digit numbers. So, bakit nga bang unique yung 12-digit numbers? Because bawat number ay may nire-represent. So, sa 12-digit numbers na yon, yung first 6 ay nagre-represent ng manufacturer ng product. And yung next 5 ay tinatawag na item number. Dahil ito naman ay nagre-represent ng actual product. So, we have two types of universal product code, the UPCA and the EAN13. So, let's differentiate the two. Yung UPCA ay 12-digit number wherein yung first digit is nagre-represent kung anong type ito ng product. Kung sapatos ba or damit ito. The next 5 digits ay nagre-represent ng manufacturer. And the next 5 digits naman ay nagre-represent ng size, color, and kung anong made yung product. And yung last digit is a check digit. On the other hand, ang EAN13 ay 13 digits code wherein yung first number ay nagre-represent ng country. And yung next 6 digits ay nagre-represent ng manufacturer and the next 5 digits ay nagre-represent ng product. And yung last number is the check digit. So both naman ay nagtatapos sa check digit. So ano nga ba yung check digit? So we have here a table wherein bawat number ay nagre-represent ng iba't ibang bagay. So check digit is the product of several calculations to confirm to the checkout scanner that the UPC or the Universal Product Code is valid. So once mali yung check digit, hindi na mai-scan yung UPC. Therefore, hindi magiging valid yung UPC. So that's it. Thank you.